Good evening, everyone. Today is Wednesday, September 18th. Welcome to the first installment of RhiNews, where we cover interesting stories that the news cycle seems to be missing out on. Everybody's tired of Trump. We're all tired of political stuff. We're all tired of right versus left. So let's just do some interesting, fun news items that don't really have much to do with politics. Well, some of them kinda, sorta, maybe. Yeah. So, joining me today, I have Prophet of Zod. Zod, why don't you tell us a little bit about yourself?
Hey, my name is Prophet of Zod. I have a YouTube channel by that same name where I talk about atheism and stuff, kind of similar to Vice Rhino, I think. And yeah, I'm happy to be here. I don't deal with science stuff very much, and we're going to talk about that some today. And I'm a little new to this format, but I think it'll be fun to sit and chat about some of these things. So thank you for having me here.
All right, thank you very much. So, to start off, Zod, the universe might be 2 billion years younger than we think. What's going on here?
Yeah, so it turns out, according to this article, for one, I guess scientists still can't make up their mind about anything, and they're always changing what they think. And we're 2 billion years younger, or closer to the young Earth model than we originally were. But according to this article, I guess scientists changed. I don't really understand the science of it that well, but they have updated their estimate from the 13.7 billion years to an estimate of 11.4 billion years. And I guess the main reasoning behind this, and I don't really understand all the science of this, is they calculate the age of the universe based on the expansion rate of stars. And so I guess the
Hubble Constant.
Yeah, they've been using this article says they'd be using a Hubble Constant of 70. And this other team came up with a Hubble Constant of 82.4. And that changed the calculation of the age of the universe, according to this article. So I had actually seen this just sitting up on a TV screen, and it got my attention. I looked it up, and I thought it sounded a little interesting.
Over the years, the Hubble Constant has had a number of different measurements, but usually it's been lower, putting the universe a bit older than that. So this is a bit of a surprising direction.
So what happens is the lower the constant, the older the universe. Is that how it works?
Yeah, it boils down to it essentially comes back to the equation of speed, distance, and time. So I don't know the precise details. I'm not a cosmologist, but I did recently do a video that covered the Hubble constant. And again, I didn't really go into detail with it, but essentially, my understanding is that the Hubble constant is a measurement of how fast the universe is expanding, so how fast the different galaxies are moving away from each other. And so the faster they're moving, the further away they are, so the older the universe has to be, I think. I don't know. This isn't really my forte.
Oh, wait, actually, the faster, if I'm just trying to think of this off the top of my head, the faster they're moving, the younger the universe might be, right?
Maybe. I don't know. Cosmology is weird. It's
like
one of those things where common sense need not apply.
If a car was driving 60 miles an hour and it was a certain distance from you, that would have meant it left more recently, right?
Yeah, so then if its speed was slower, then it would be closer, so it would have...
If the car were driving 30 miles an hour and it were a mile away from you, that meant it left.
Yeah, this is why it doesn't come back exactly to this equation, because it's not quite the same thing, because it's the actual space itself in between items is expanding, so it's not necessarily that the stars are moving away faster, it's that the space in between them is expanding faster.
And that's where I'm trying to imply my very much layman's intuition to this problem to get a general sense of how they apply, but I really don't know.
Yeah, me neither.
Yeah,
but that's still fascinating. We might be saying 11.2 billion in the future. I don't know. I thought the 13.7 was pretty sturdy. I feel like this is something that will need to be replicated a number of times before it becomes the general consensus. Because this is just one study, and that's something you'll see a lot in science, is that one study can often give very, very wildly surprising results, but then when it's replicated, it's found out, oh, they did this wrong in that study, so the results don't quite hold up. Or if the study does hold up, then when they replicate it, they find the same results. But as our instruments get more sensitive, I think we'll do better at measuring the Hubble constant, and so we will hone in on as we get better, we'll hone in on a much more precise age for the universe, even if it's still 13.7, but now we know it's 13.72.
Yeah.
Sort of thing. Like the margin for error will get smaller. But yeah, that certainly is interesting.
And this doesn't really mean much to me one way or the other, to be fully honest. Like if science, like you said, one study changing the age of changing their estimate of the age of the universe, I really don't think really is that ground shaking or anything. And that, yeah, like you said, it doesn't really mean anything until it's.
We'd have to reevaluate how we measure the ages of stars, because that was actually one of the issues. The oldest star in the universe, with the measurement techniques that we use, we actually got an age older than the entire universe for that star. But the margin for error with that measurement put it just under the oldest age of the universe. So that star did kind of line up with it. But 11.2 billion years is well below what the margin for error on that star was. So this doesn't really jive with that measurement, unless the methods that they used to calculate the Hubble constant with this would have had something to do with that measurement, and so it would apply and change that age. I'm not sure. You can't have stars that are older than the universe.
Yeah, I would think not. And this stuff mostly goes over my head, and what I hear personally is scientists are constantly working things out, or constantly adjusting and reevaluating, and there's always going to be flash in the pan stories like this. And to me, it's just kind of interesting to have some vague sense of how they do their job. And I think what else is interesting to me, and what really gets my attention when I see something like this, is what instantly enters my head is how creationists or Christians process something like this. Like I always hear Kent Hovind in the back of my mind saying, well, scientists can't make up their mind about anything, or in this textbook from the 80s, they had this age and stuff like that.
Yeah.
Yeah. So I don't know if that's.
I wouldn't necessarily lump all Christians in with that. Certainly within the general Christian population, there does tend to be a little bit of a lag, like with how evolution was a thing for about 150 years before the Pope finally came out and said, oh yeah, by the way, evolution is a thing. We know this now. So there's a bit of a lag there, but I think it's the young Earth creationists that would really have issues with this. I think more mainline Christians, like the people over at BioLogos, they're fine with it.
Oh yeah,
as long as
that's a problem I usually have, is I say things in a way that lump a lot of Christians into things where they don't belong. But I'm speaking from my personal history and how I've heard people process that. That's part of my interest in this, is how people absorb this knowledge and stuff like that. But yeah.
Those of us who spend a good chunk of our time making videos responding to young Earth creationism, it can often be hard to keep a mental a mental wall in between this is a young Earth creationist versus this is a Christian. It all just kind of blends together, and we actually have to try to not let them blend together. All right, so moving on. Transformative new device harvests energy in darkness. That sounds ominous. Now, this is a story about a gentleman named Aswath Rahman, or Raman, or Raman. I'm not sure. It's spelled like the noodles. So Aswath Rahman was driving through a village in Sierra Leone in 2013, and he didn't even notice that he was driving through a village until he was halfway through it, because they didn't have any lights on, because they have zero lights. They don't have electricity, so at night it's just dark. And there are a lot of little villages in remote places in the world that they don't have consistent, reliable sources of electricity. They might rely on solar power during the day, but batteries are expensive, so they don't have lights at night and things like that. So he was trying to figure out what he could do to help solve this problem. So he developed a generator. It's a thermoelectric generator that uses the fact that the Earth cools off quite a bit when the sun's not directly shining on it to produce electricity using the Seebeck effect. The Seebeck effect is when there's a temperature difference between two electrical conductors of a different material, and the difference in temperature and how the two different materials handle the difference in temperature and how the electrons move within those materials produces a voltage difference between these two materials, which can then be harnessed. It's not a very efficient way of producing electricity, but it's enough to power an LED bulb. Like they were able to get a little white LED bulb. They only got it to about 10% of its peak brightness. So it's not very much, but the device was also fairly small. It was only 1 square meter, and it's completely modular. So you can hook several of them together, and you can move them around, put them where they're needed. And this would potentially be a good way to get light to remote areas that they need lights on at night. Or this could also have scientific purposes where they could use these devices to power sensors that are like sensing the weather in remote locations, and they don't have to worry. There's no moving parts. It's got a life expectancy that is greater than that of solar panels, and they don't have to worry about battery backup at night. So you could have a solar panel powering it during the day, and this thing would power it at night. So you could have sensors out in remote locations that you don't really have to worry about maintenance on them, because it doesn't need maintenance. So I thought that was a neat little story of something that it's not a huge leap forward technologically speaking. Like we've known about the Seebeck effect for 200 years, almost 300 years now. We've been using it to generate like electricity for a while now. It's just not a very efficient method, so it doesn't really catch on. And these are actually very cheap devices. I mean, I read the paper, and he said he spent about $30 on all the parts for it.
Oh, wow.
I know you can actually go to Amazon right now and buy a thermoelectric generator for $5.
Huh.
I don't know how efficient that one would be compared to his device. I don't know. Obviously, it's not like you can't just sit it outside during the day and then it'll cool off on its own. Like that part of it is part of his device. But it's still pretty neat. Like the lighting in dark areas is one of the best ways to prevent crime.
Yeah.
Like we had problems when we moved into the house that we live in with kids at night would do things like come onto our porch and cut our Christmas lights off. Like they cut individual bulbs off all the Christmas lights. And they just do stupid stuff like that on a fairly regular basis. As soon as we installed a motion sensing light that just turns on when somebody walks past it, it hasn't happened once since then. So just having light there is a great way to prevent crime, especially in these rural, remote communities that they don't have the resources to catch a criminal.
Yeah.
So prevention is key. And
I'm sure that's one of those things that we just take for granted, but as soon as you think about what it's like to not have it, it's a pretty big deal.
Yeah.
So I don't totally have my mind around how this all works, but essentially it works as you let it warm up during the day, and then at night as it cools, that produces power too, roughly speaking.
Yes. So it uses it has a radiative cooling mechanism where it'll keep the two materials separated, and it uses a cooling plate at the top that radiates the heat that it collected during the day out into space, essentially.
Yeah.
And then because of the difference in temperature between the bottom and the top, and they're made of two different materials that respond to the difference in temperature differently, it produces a voltage difference, which is then used to power the lights.
And so he essentially improved a little bit and found a good application where it might not generally be efficient.
Yeah.
Otherwise. That's interesting. I like that.
Yeah. So he didn't really invent anything new. He just applied it in a different way, in a novel way. This is really kind of the backbone of science, because you hear about all these big breakthroughs, and there are certain scientists whose names go down in history for making a big breakthrough, but realistically, they all just made small incremental improvements on the people that came before them. And this is a good example of that. Like if this pans out and it turns out that it is scalable, and it actually ends up being a great way to bring electricity to these remote communities at night, this could end up being a very important invention.
Yeah, it seems like it. And to me, that's what I like about this, because I'm not a scientist, and I don't really understand how they build all these things. But I find it very satisfying, and I kind of like when people find something that just find an application, just find a way to plug it in and make something that wasn't otherwise very efficient, find a way that it works. So that's really interesting.
Yeah. Okay, so moving on. Climate change may be throwing coral sex out of sync. Do corals have sex? Or is this the sex of the fish at the coral reef?
This is actually the coral itself, which is pretty interesting. And you might think that sounds mundane, but hang in here, because it's actually
When
better
have
than
I
you
ever
would
thought
think.
sex of anything sounds mundane?
Okay, not you, but other people might. But yeah, it was a pretty crazy article for a few different reasons. Um, One, I think I do need to share what this process is like. Basically, it says a bunch of coral when they're together of the same species will typically let colorful egg sperm bundles float out of their tiny mouths and up into the water on the same few nights a year.
Kinky.
Yeah, so you know that was, I don't know, the fact that corals spit sperm and egg bundles out and then they meet each other. That was, yeah, interesting to me.
Reproduction by vomit.
Yeah, essentially. Um, Picturing humans doing this makes an interesting
It's two
picture.
girls, one cup.
Yeah, something like that. But then essentially what happens is this is how the coral reproduces, and because of climate change and how that's affected the water temperature, um, more or less as I understand it, it's throwing off the timing between some of these coral, and they're not releasing these bundles on the same schedule that they used to, and they're not spawning when
So
they're not spawning when they're expected to, and so they're seeing,
the sperm are missing the eggs?
yeah, roughly speaking, the coral aren't throwing out in sync with each other, and so there's a decrease in coral reproduction, and they're thinking this could drastically affect the coral population over time.
So it's not enough that climate change is causing the coral to bleach and die. We're also messing with their reproductive cycle.
Yeah,
So just for the record, human-driven climate change is a thing. We are totally causing this. And like anyone who thinks like I know I actually in a former life I used to be kind of libertarian leaning, and I remember reading about climate change and how they would say, oh, it could actually be a good thing. We don't actually know what all the consequences are. So why is everybody being so alarmist about it? It might be good. You know, if the northern regions warm up, they'll have a longer tourist season. So it'll drive more tourism. So everybody makes more money. And they'd have ridiculous arguments like that. But no, we are killing essential organisms in the ocean. Coral are very important. Like they provide the backbone of the entire ecosystem of these marine shallow environments, and we're destroying them just by having slightly warmer seas. You know, it 1 or 2 degrees Celsius doesn't sound like a lot, considering that like there's a bigger difference than 1 or 2 degrees Celsius in between midnight and noon. So what's 1 or 2 degrees? That's nothing, right? But it's the global average. If the entire global average goes up by 1 or 2 degrees, it's going to be a nightmare. And part of it is we're going to start to see all these fish species die off as their host corals die off.
yeah, and it says they're synchronized the same half hour, I think, within a year, and this depends on a lot of things. It says they take cues from water temperature, sunlight, wind, and I think even phases of the moon. And so there's a lot of stuff that goes
Wow.
into all this coming together and happening. And I guess it's pretty crazy. They have some pictures, and the guy says you could actually sit there and watch these bundles come up into the water and everything. And yeah, so this stuff really, I don't. Climate change should be on your mind. I probably don't think about it as much as I should, but when I see stories like this, along from the fact that the title kind of grabs your attention because it's coral having sex and everything, it really is kind of freaky, the number of things beyond just global temperatures and things melting and stuff like that. All the little tiny things that changes in global temperature do that can have a really big impact. That really brings the scope of the problem to mind for me, and helps me appreciate how many little things that we really can't fix or take back are probably already happening.
Well, I will say one thing. The picture of all the little sperm bundles floating through the water, those are the prettiest sperm bundles I've ever seen.
I'd say I'd agree. I haven't seen many, but yeah, I would guess that's probably prettier on average than most of them.
All right. Well, thanks for that. Now, next up, we have astronomers find water vapor in the atmosphere of a habitable zone exoplanet for the first time. Um, I know we found water before, but I think we usually find water vapor around gas giants, just because the way we measure what's in the atmosphere of an exoplanet, as the planet goes in front of its host star, like as the light comes through it, it separates out into a spectrum. We analyze the spectrum, and different elements have different signatures on the spectrum, and so water vapor has its own spectral signature. But we're not usually able to do it with smaller planets that we would think of as being able to support life, so Earth-like planets. This one, what's interesting about it is a rocky planet. It's about twice the size of Earth, so it's not exactly Earth-like. It's a rocky planet. It's within its star's quote-unquote habitable zone. We know from studying our own solar system that the habitable zone isn't necessarily the only place where you can find liquid water, but it's definitely a great place to start looking. Now, one of the problems with this planet, as far as supporting life goes, is it is orbiting a red dwarf, which they are usually very active stars. They send out a lot of stellar radiation. There's a lot of coronal mass ejections from them. But the star that this one's around is actually fairly quiet. So the surface temperatures on this planet, which is named K218b, which sounds like a Star Wars droid, the temperatures on this planet range from minus 73 degrees Celsius to 47 degrees Celsius. That's about negative 100 Fahrenheit to 116 Fahrenheit. And as a reference point, the variation in temperatures on the Earth are from negative 84 Celsius to 49 Celsius. So it's actually got a narrower range of temperature. So in that sense, it would be easier for life to exist, but then it's twice the size of Earth, so the gravity is quite a bit bigger. I believe there's an inverse thing going on, so it wouldn't be twice the gravity; it would be more like 4 times the gravity.
Oh, wow.
So yeah, it's not necessarily a great planet to look for life. So there are three possible models that they have for how much water there is in this planet's atmosphere. One of the models has it having no clouds, and the atmosphere would be about 20 to 50% water vapor. And in the second and third models, there would be clouds, and the planet's atmosphere would contain between 0.01% and 12.5% water. So they're saying that it could have 0.01% water vapor to 50%. So that's a massive range.
Yeah.
They're really kind of hedging their bets in this one. I thought this was an interesting story because this is the first time we've found a rocky exoplanet with water in a habitable zone of a star that it's not the kind of star we would want to start searching for life around, but this particular one is inactive enough that it's more possible than with others of its kind. This is a really neat news item for me. Now, of course, we're not going to, it's 110 light years away, so we're not going to be exploring this in our lifetimes. Probably the only one that we'd be able to explore while either of us are still alive would be Proxima Centauri b, which is 4 light years away. And if we use solar sail technology propelled by lasers, and we do really, really well with this technology, we might be able to get a probe there in 20 years, like 20 years from the launch date, not 20 years from now. And then once the probe does get there, you might get like a week of pictures, but it's going so fast you can't possibly slow it down. It's just going to fly right through.
Yeah.
So it would be a really long wait for potentially something that's not of great interest to the public. I'm sure the scientific community would absolutely go nuts to have that sort of data, but if there's not little green men there, then the public doesn't necessarily care.
Yeah, and that's unfortunate. I like these kinds of stories because I've always been fascinated by the space program since I was younger. And so to me, just hearing the possibilities of what they might be finding, obviously they're not likely to find something dramatic based on this, but just seeing little pieces of the puzzle come together, and it blows my mind how they even determine that this is, this much stuff about these planets.
They're actually they're going to be taking a closer look at it when they get the James Webb telescope up there, because right now they're looking at it with Hubble, which Hubble's an amazing telescope, but the thing is outdated at this point. It's been up there for 20 years now?
Yeah, I think so.
It's time to retire. And this also, it is worth noting that this has already been replicated as the study that found the water vapor has already been replicated. There were 2 studies happening at the same time. They published within 1 day of each other. And the 2 teams of scientists do have some disagreements over the details. Like that's where we get the wide variation between 0.01% water vapor to 50%.
Yeah.
Because one team came out with the 20 to 50%, and then the other team was the 0.1 or 0.01 to 12.5%. But it's been confirmed by 2 separate teams that were competing with each other. They were not working together on this. But they both confirm that there is, in fact, water vapor there. So
Yeah.
it's a planet that's not entirely hostile to life. So the idea that we are alone in the universe just looks more and more ridiculous the more data we collect.
Yeah, even if they don't find life, to me, it's just interesting to see what's out there and how many Earth-like planets probably are out there. Yeah, so it's an interesting story. I like hearing about any other kinds of planets out there, but especially anything that's Earth-like or might possibly be habitable. It's pretty fascinating to me.
So that's it for news items today. Before we go, it's time for the history lesson of the day. On this day in 1872, King Oscar II of Sweden and Norway ascended the throne. He is important because he is who King Oscar sardines are named after, and also the Oscar topper that you might get on your steak at a steakhouse, which is crab cake with asparagus and béarnaise sauce. That was named after him because he would put that on his venison all the time. So naturally, we took it from venison and slopped it on a steak.
That is very interesting. So essentially, a king I had never heard of has had food I've never heard of named after him.
King Oscar II was king for 35 years, and his legacy is a sardine company that's named after him and a topping that people charge way too much for at steakhouses.
Nice. I guess you have to do something if you're eating venison.
Yeah, I mean, his legacy is more than most of ours will be, I guess. It's a bit of a dark way to look at it, but... Okay, well, thank you so much for joining me, Zod, for this inaugural episode of Viced RhiNews. It's been the kinky episode. We're working out the kinks. The format will probably change as I get better. Like, go back and watch the first video I ever uploaded. That thing is garbage. I will get better at this. I promise. But thank you for helping me work out the kinks, Zod.
Yeah, thank you for having me on. I appreciate it. Science isn't really my area of expertise, but I was glad I could show up and chat with you about it anyway.
All right, so thank you so much. And if you liked what you saw today, feel free to go check out Zod's channel. Link will be in the description. And have a good day. See you next time. I'll record a close that actually sounds cool later. Bye.